Hello everyone, today I will be demonstrating my ECE 5000 project. My project is the door monitor. It monitors the door status and sends the data to ThinkSpeak. The first thing, I'm gonna show the display, the output of the device on the serial monitor on my laptop. To begin, I'm gonna connect the USB cable to my laptop. So once connected, it connects to Memorial's Wi-Fi, and then it displays the network SSID and displays the IP address. The IP address here has been deleted for security purposes. Then it measures the voltage, which is 0.00 in this case. This is because we're running on the USB cable, not the backup battery. Then this data being uploaded to ThinkSpeak, and then we have to wait 15 seconds before we move on, because the free version of ThinkSpeak doesn't allow to update data in an interval less than 15 seconds. After that, it displays the doors status. So the doors are basically read switches, and to indicate that they are open or closed, we have this magnet. Once it's close to the read switch, it means that the door is closed, and if it's away, it means the door is open. I'm gonna place the magnet here near the one of the read switches, and I'm gonna show the serial monitor. So now in this case it should be closed. If we look here, it says door 1 is closed, and we have 200. 200 basically is the response we get from the ThinkSpeak server. It means that the request has been sent to ThinkSpeak and it was successful. The closed status has been updated now in ThinkSpeak, and we have waited 15 seconds, and then the sampling begin again. This process just goes on for the 3 doors and the battery voltage. Now here we have the ThinkSpeak dashboard. The dashboard contains multiple graphs. They identify the door status and the battery voltage. First, here we have a histogram or a bar chart. This displays which door has been opened the most or has been used the most. We have the main door, the side door, and the third door. In this case, both the side and the third door has been opened 8 times, while the main door has been opened only 7 times. Now for each door we have this chart. This chart basically displays the open and closing event for each door with the time. So this means now for this door it has been open since the time 1630 to 1645. So all this interval has been open while this interval has been closed. This graph is for all the 3 doors. Now I'm connected to only 2 doors, the main and the side door. The third door has not been used yet because it uses the third switch, while I have only 2 switches for now. Now the two charts in the bottom, they are for the battery voltage. This is the numerical voltage value of the battery, and this is the voltage over time. To begin, I'm gonna disconnect the USB cable, and I'm gonna be running on the battery voltage only. So what I did is I disconnected the USB cable and I pressed this rocker switch to connect the backup battery so that the device now is running on the backup battery. Now if we see here, immediately the voltage value jumps to 4.46. This is the current voltage of my battery. Also the graph here has been updated. Now in the beginning of this video I have placed this switch, the main door, I have placed the magnets near the main door switch. This means it's closed. You can see now here it's in the closed status. Now I have removed the magnet away to display that now the chart is gonna be updated. For these charts specifically, I have used MATLAB scripts to create them. This gives me flexibility in manipulating the y-axis and the x-axis. And instead of displaying 0 and 1 on the y-axis, now I can display closed and open. However, since I'm using the free version, these charts are not being updated in real time. Like we saw that the voltage updates by itself without refreshing the page, but this is not the same case for these graphs because we are in the free subscription. So once I refresh the page, now you could see that the status went from 0 to 1, or sorry, from closed to open. This interval here identifies how much this door has been closed. Now when I open the enclosure, we have the backup battery inside, and we have the ESP32 with its prototyping PCB. Now the cables coming from the battery and from the switches has been connected to the PCB through these pin headers. They have screws to ensure that these connections are not loose. I also have this snap fit enclosure lid. I don't need any screws to put it back, just have to press on it. Thank you everyone for watching. This was my project test for ECE 5000, the door monitor. Thank you.